Okay, now we're going to go into some basic probability today. And I'm going to give you the Easter egg now. It is 754367. That's 754367. That's for these two sections, 11.3 and 11.4. All right, we're going to talk about basic probability, theoretical probability, and then what's called empirical or probability taken from experiments is the second one. If an event E, we call it, has n of E, that means we're counting now, equally likely outcomes, and its sample space S has n of S equally likely outcomes, the theoretical probability is denoted by P of E is number of outcomes in the event E divided by the total number of possible outcomes. Okay, so basically, how many possible outcomes are there? So if we roll a dice, there are 6 outcomes. And what's the probability of rolling a 1? Well, that would be 1 in 6, because the number of outcomes in event E, the event E we're talking about is rolling a 1. Well, there's only one 1. If I was rolling a dice that had 2 1s, 2 2s, and 2 3s, then what would be the probability of rolling a 1? Well, the number of outcomes in event E, the event E I'm asking for is rolling a 1. There's 2 1s, so the numerator would be 2. This would be 2. And this would still be 6 because there's still 6 possible sides. So I have a 2 in 6 chance or a 1 in 3 chance because there's 6 sides on the dice. Okay? So that's what probability is. It's really pretty simple. So the sample space, which is a term used here, the sample space, I'll just define that a little bit more clearly. The sample space is the set of all possible desired outcomes in an experiment. It's a set of all possible desired outcomes in an experiment. Let's just hit up some examples and we can start to get a handle on this, okay? I'm going to erase this definition. So basically, another way to think about this is the probability, theoretical probability, is the number of desired outcomes divided by the number of possible outcomes, all right? So let me pull up an example. Here we go. Our die is rolled once, find the probability of rolling a 2. So let's go with that. So a 2. Well, the number of desired outcomes, that's the number in the sample space, would be 1. There's only 1 2. And there's 6 sides. So 1/6. That's an easy one. A number less than 4. Well, how many possible numbers are there less than 4 on a dice? Well, there's 1, 2, and 3. So there's 3 possible things in the sample space. That's desired outcomes. Divided by the still number is 6. So that'd be 1/2 reduced. A number greater than 7, well, that'd be a probability of 0 because there are no, on a 6-sided die, we're assuming a 6-sided die in all these, there are no numbers greater than 7. A number less than 7, well, how many desired outcomes are there less than 7? Well, there's 6. You could roll 1, 2, 3, 4, 5, or 6, and there are 6 possible, so the probability is 1. You're guaranteed to roll a number less than 7. If the probability of something is 0, guys, that means it can't happen. It's impossible. If the probability is 1, that means it's guaranteed to happen. And everything else in between is a ratio between that. Okay, let's do some more problems. You are dealt 1 card from the standard deck, 52-card deck. Find the probability dealt an ace. Let's start with that. Well, how many aces are in the deck? So the probability of this event, sorry, well, let's put right in here. Probability of an ace. Okay, we'll just use that notation. Probability of an ace. Well, there are 4 aces in the deck, and there are 52 cards. So that'd be 1 in 13 if I reduce that. That one's pretty easy as well. Find the probability of a red card. Well, probability of a red card. Well, there are half the deck is red. Is that correct? So there are 26 red cards, and there are 26 black cards, and there's 52 total cards. So this is desired outcomes divided by possible outcomes. Again, so that's 1/2. You have a 50-50 chance of pulling out a red card. A red king. Well, how many red kings are there? Well, there's 4 kings. Probability of a red king. There are 4 kings. 2 of them are red and 2 of them are black. So this would be 2 out of 52, which is 1 out of 26 chance of pulling out a red king. Okay, now we're going to talk about empirical probability. This means experimental. A lot of times we don't have a theoretical probability for something. Like with a dice, we know there's 6 outcomes, and we know that we can figure out theoretically what's going to roll as long as it's a fair dice, it's not weighted or anything. But in the real world, sometimes we want to figure out what's called an empirical probability. Like maybe we don't know the number of possible outcomes, and we don't know exactly all the cases, and so we're just going with an experiment. Like for example, with coronavirus. We don't exactly know how many people have been infected, and we don't know how many cases there have been because the testing is not awesome right now. So what we do is we just take the number of cases that we are aware of, that'd be the total number of observed occurrences, and then we find the total number of deaths from COVID, and we just divide them to get what's called a case fatality rate. And that gives us a probability on somebody dying of COVID-19. But it's not an exact theoretical probability because we don't have all the data. We're just using the experiment to the best of our ability to make a prediction, okay? So what's an example? So in that one, we have the number of times we observe it, which is not necessarily all the times that it exists. It's just the number of times that we are able to observe it. And then we look at the total number of observed occurrences. So the COVID example is an example. How many cases have we seen? That'd be here. Cases. Total that we've observed. And then how many deaths have we observed? Okay. That would be an example from what we're going through right now. So let's look at an example from the book. Okay, we got a table here. If one person is randomly selected from the population described in table 11.3 above, find the probability expresses the decimal rounded to the nearest hundredth that the person has never been married. Okay, so first we need to figure out how many people have never been married. Well, it looks like the total of the number of people that have never been married is right there, 74. Okay, so the number of people that have never married is 74. Well, let's write this formally, sorry. The probability of never married. This is the proper way, okay? There are 74 people never married out of a total of, looks like 242 people. So let's just put that into the calculator. 74 divided by 242. And that is 0.31. So about a 31% chance of people that have never been married, okay? How about percentage that are male? Well, how many males are there? Well, it looks like the probability of being male, according to this table. Well, that would be, looks like there's 118 males, and there are a total of 242 people. It's really simple. So this is all just table reading. Looks like that is roughly 49%. Sorry, my bad. I shouldn't write that as a percent. That's the way I've done it in the classes. My bad. So anyway, as a decimal, I get 0.49. So about 49% chance. Okay. So this should get you ready for the homework for that. That section's pretty basic. Those examples should get you going. And if not, let's set up some Zoom meetings and get your questions sorted out. Sorry.